Okay, this is to show you what we do about the metal inserts and how we tumble them and prepare them for bonding to the rubber, because some of the molds where we're making carburetor sockets require that these metal pieces, which these things have been laser cut. I have these done at the hole shop, or any laser cutting place can make these for you. They're so cheap to get them cut out with the laser that I don't even drill these holes anymore. The holes are put in there and everything. The computer just goes around and cuts these out so fast out of a piece of steel, and then they just drop on the floor. It's like a big computer printer that does the cutting, and the parts drop out, and they just pick the parts out of the burnouts and stuff, the pieces that come out of the center and everything, and a lot of swarf on the floor. They sweep them up and pick out these parts, and because of that they're usually a little bit dirty, so I've rinsed them off in a little bit of water. But what I'm going to do now is tumble them. Tumbling them helps take scale off of the part. It rounds off the edges so as to prevent a stress point in the rubber where there's a sharp edge. So I want these to be as good a quality part as I can get, so I always tumble them. After they're tumbled, they'll be blasted with shot, and we'll shot blast them and try to get them as rough as we can so that the rubber really bonds well to the steel. But first is the tumbling operation, and for that we use this stuff here. This is a ceramic media that we're going to blast them or tumble them with. I used to use just driveway gravel, and that works just fine too. But after a while I decided, well, this stuff really lasts a long time. It doesn't wear out so fast as gravel does. And it will be put into here, into this tumbler, along with some of these metal parts. Let's see if I can pour these in while I hold the camera. It was getting a little low on. You see they get wore down kind of small. And once they get wore down, they still work. But I thought it was time to add some new media to it. These are made of ceramic, I guess, but they have some sort of an abrasive mixed into with them, and that's what does the cutting. So I'll put in the metal plates in there along with water. Fill it up about halfway with water, and I always put a little dash of soap in there, and that tends to keep the grit free. I think it floats the little pieces of steel that are being cut off, and I think it makes it work a little bit faster with just a small dash of soap. You don't have to put much, just a little tiny bit in there, and that seems to work real well. Okay, now what I have in there is some water and about 24 of these metal inserts. I can put about 24 at a time in these, because these are pretty small or lightweight metal inserts. These are going to go for a Kawasaki 440 carburetor flange socket. They also are used on the Honda 360 flange sockets. And I put about 24 of them in there along with the media and some water and just a dash of soap. And so now we're ready to put the cover on here and bolt it down. This tumbler is all lined with rubber, and then we'll be ready to tumble, and I'll show you what that does as soon as I get done here. Okay, now we have the tumbler turning on there. I always do this in the garage because, as you can hear, it does make a little bit of noise, so there's no sense in doing it in the house and making a lot of racket and distraction in there. It'll have to run here probably overnight. By tomorrow I can come out here, and if they run in there 24 hours, all those plates will be nicely rounded off, and I'll show you what they look like after they're done. Good morning. Okay, these things have been running in the tumbler now. These metal inserts, these flanges have been running for about 24 hours. And you can see the difference in what they look like over what they look like when they came from the laser cutting outfit that cuts them out for me. And you can see the difference in the finish. It takes all the scale off, and in particular what I'm trying to do is round off sharp edges, particularly on the inside of this hole right here. You can see that corner is kind of rounded off in there now, and that's the effect I'm trying to get. If you leave them in there for 2 or 3 days, it doesn't hurt anything. It'll just round them off even more. But now that all the rust and scale and swarf has been removed from them, now what I want to do is get them as rough as I can, which means I'm going to take and blast them with as rough a media as I can. I used to use sand, but sand is cheap, but it doesn't last that long, and it breaks down and kind of turns into a real fine dust that kind of plugs up the blaster. And so I use some silicon carbide, which is expensive, but it basically lasts just about forever as far as a abrasive cutting thing. And you can also use something called shot. I think that they're like little pieces of slag steel or something that when you blast something with it, it'll really make it rough. But that's what we're going to try to do, is roughen them up, and then we're going to soak these things in some solvent to make sure that they're really clean before we dip them to get them prepped for putting in the mold. Okay, now this is a close-up view of what they look like after they've been blasted. And you can see that they have kind of a flat appearance. The most important part I try to blast well is inside this hole here, because that's where I want the rubber to really stick good, is inside there. The outside of it I'm not too worried about, but the inside I'd like to blast it. And of course now the next step is to take them out of here, put them in this pan where we're going to use acetone to clean them. I like using acetone because it really dries fast. It leaves no residue, but it's extremely flammable, so you want to be really, really careful if you're using acetone. The other good thing about acetone is it will clean rubber off of something. It'll cause rubber to swell. It virtually destroys rubber, so if you're trying to get rubber off of a part, soaking it in acetone or MEK is really the way to do it. MEK does not evaporate as fast as acetone, but it cleans real well also, but it has a very strong odor to it, so I'm not real keen on MEK. I like the acetone better, and that's what I use. Now the next step after we get them washed off with acetone is we'll hang them up to dry, and then they're ready to dip. Okay, now I'm ready to dip these in the vulcanizing agent, which is a special sort of mixture chemical that's used to bond the rubber that I use to the steel. It'll bond to steel or aluminum or probably just about anything, plastic, whatnot. I think if you wanted to mold something into a piece of rubber and have that rubber be vulcanized right to it, such as a motor mount or something like that, maybe a flex coupling, flex drive coupling, something where you have to have a metal insert and the rubbers have got to really be stuck to it, then this is the stuff you need. Now what I do is I just have, you see bent pieces of coat hanger. They're sticking here in a vise, and I'm doing this out in the garage, mostly because it makes a bit of a smell, and I got a workbench and a nice big vise to do it, so that's why I'm doing it out here. But I'm not too proud of this setup, but that's the only thing I ever came up when the parts hang on that rod right here. I just clamped it in the vise, and I hang them on there with the coat hanger, and dip them in the stuff, and it drips off onto these newspapers I put on the floor. Not too sophisticated, but that's the way I've been doing it, and like you say, whenever you set something up, you want to do it right to start with, because you'll never end up making it better. And the stuff we dip them in is right down in there. To mix it, I just shake it up. I turned the can upside down and shook it. As you can see, it made some air bubbles in there, but that doesn't seem to hurt it any. It's sort of like a paint, but I think it has MEK in it. It does have a little bit of a smell to it, although it's not too objectionable, but I don't think you'd want to do it in the house if you could help it. So now I'm ready to dip them. Now, one problem I did want to point out to you is when you dip these things, I don't know if it's static electricity or what, but when you pull them out of this stuff, they may tend to stick together. These won't, because there's only 3 on this hook and there's plenty of distance in between them. But ones like this, they get pretty close together and they may want to touch. Well, I just get my finger and kind of poke at them and see how they go together like that. You don't want that. You get them straightened out there, see? So they're not touching each other. Because otherwise that'll make a spot where the stuff, the paint isn't on there. So anyways, that's what I'm trying to do. Kind of hard to do and take a picture at the same time, but anyways, that's the idea. So that if you put too many on a hook, you're going to have a lot of trouble with them sticking together. So anyways, that pretty much covers the dipping them. And of course, I can tell you exactly what type of material to use to put on these things. There's certain types of this paint that goes on there depending on what type of rubber you're using. Now, one more point I wanted to make about this gallon can of this paint here that we're dipping these things in. I've found that you can increase the shelf life of this considerably just by freezing it. So I keep this gallon in the freezer when I'm not dipping parts in it. I get it out to dip the parts, let it warm up, shake it up real good, and then dip the parts in it. And then after I'm done using it, I put the cap back on there tight, shake it up again, and then I put it back in the freezer. This stuff is kind of expensive. This gallon can is about $350, I think. Part of it is the cost of the shipping because it's hazardous. It has MEK in it. And UPS, if they want to ship something, they want big money for it. So there may be things you could do cheaper about that. I don't know. I'd get the little tiny cans of it and I would paint these with a brush. But instead, I'd rather just get one of these big cans every 2 or 3 years and use it to dip them, because dipping is so much faster than trying to put it on there with a brush and paint one side and then paint the other side, and it's just a big mess. And dipping them seems to be the fastest and easiest way to do it. If you let these set here for a few hours, they'll dry. It dries fairly fast, and then they'll be ready to mold. And I usually put them in a little box and keep them. You can keep them for quite a while after they've been painted, as long as you keep them out of a damp condition or anything like that. You can keep these inserts ready to go to put in the mold, where they're already painted and ready to go, and you're ready to mold with them. I don't really know how long you could keep it, maybe a year or something. I really don't know, but I would think after they're painted, the stuff will still vulcanize on there. You can always test it when you run a part. You can test that first part and see if that rubber's stuck real good to the plate. If you can't get it off that metal plate, chances are nobody else can either. So it's always a good idea to check it.